All right, so we got 2017 for response number 6, which means it is not a calculator problem, so you guys should not be using a calculator. So we got some instructions here. We got some tables, a graph, equations. It's got everything. So let f be the function defined by f of x equals cosine of 2x plus e to the sine of x. Let g be a differentiable function. Okay, the table above gives values of g and the derivative g prime. And let h be the function whose graph consists of 5 line segments. All right, so we're going to be using all of this information at some point throughout this problem. So let's begin with part A. All right, so part A is asking us, find the slope of the line tangent to the graph of f at x equals pi. So find the slope. Isn't that just going to be the derivative? So I want to begin by finding f prime of x. Alright, so we've got the chain rule going on here. So the derivative of cosine is going to be a negative sine. Okay, remember the inside part's going to stay the same. But then we need to multiply by the derivative of the inside. So the derivative of 2x is 2. So I'm just going to write that 2 out front. Okay, so we got negative 2 sine of 2x plus the derivative of e to the sine of x. Well, derivative of e is just going to be e to the sine of x times the derivative of the inside. So our inside's kind of like our exponent here. So the derivative of sine of x is going to be positive cosine of x. Alright, so that's my derivative, but it's asking me find the slope of the line tangent to the graph of f at x equals pi. So now I really just need to plug in pi. So I get f prime of pi is going to equal negative 2 sine of 2 pi plus cosine of pi e to the sine of pi. Alright, so in the past we've been told every once in a while that we can leave it just like this, but we've also been told that we need to evaluate our trig. So I'm going to evaluate the trig just to be safe. Okay, so we got sine of 2 pi, so I'm going to look at my circle here. 2 pi is not just one full rotation around, so we're back at 0. Okay, sine is my y value. My y value at that location is going to be 0. So, f prime of pi, this part's just going to go away, so it's going to equal cosine of pi now. So pi is over here. Cosine is my x value. My x value at that location is going to be negative 1. E to the sine of pi, well, pi is over here, sine is my y value at that location is going to be 0. Okay, you could leave it just like this. We also know e to the 0 is going to be 1, so that would end up being negative 1. Alright, that was fun.
Very fun.
Very fun. Let's move on to part B now. What do we have in store for us here? Ooh, let k be the function defined by k of x equals h of f of x. Find k prime of pi. Brand new equation.
Because we need more letters on this problem, Mr. Murphy.
Yeah. There are all sorts of letters. H of f of x. So we need to find k prime of pi. Lots of pi on this problem too. So I got first find k prime. So k prime. Okay, so we got a chain rule here. So we need to remember to take the derivative of the outside. So it's going to be h prime. Our inside part's going to stay the same. So that's still going to be f of x. Times the derivative of the inside, which we would write as f prime of x. Okay, so that's our derivative, but we want to know our derivative at pi. So I've got k prime of pi now. So remember, we're just going to be replacing all of our x's with the pi. So it's going to be h prime of f of pi times f prime of pi. Alright, so we already found f prime of pi, and we know that's going to be -1, but we still don't know f of pi, so we need to figure out what in the world f of pi is. So I'm just going to do that guy separately. So f of pi, do I have enough room here? This is going to equal cosine of 2 pi plus e to the sine of pi. Okay, cosine of 2 pi, remember 2 pi is 1 full rotation. Cosine is my x value. My x value up there is going to be 1. So we get f prime of pi is going to equal 1 plus e to the sine of pi. Well, sine of pi is over here. Okay, sine is our y value, so it's going to be 0 again. So this is going to be plus e to the 0, which is going to be 1, not 0. So this is really going to make 1 plus 1, which is 2. So f of pi is going to be 2. So going back over here, we now have k prime of pi equals h prime. We know that f of pi is going to be 2. And we already know that f prime of pi was -1. So now we need to figure out what is h prime of 2.
Whoa!
So looking at all this, we have our graph of h here. So if we want h prime, isn't h prime going to be the slope of h? So I want to look here at 2. What is the slope at x equals 2? Well, I'm going down 1 over 3, so that's going to be a slope of -1/3. So this is going to be -1/3 times -1, and you could leave it like that, or you could just say it's going to be +1/3. So k prime of pi is going to equal +1 over 3.
That's good stuff right there.
Okay, you guys, we always say you want to stop as soon as you can. You can't stop until you actually figure out what h prime of 2 is. Okay, so if you have to actually evaluate something, you're going to need to figure out what that is, because it's very important for your understanding of this problem.
Or pull a number off of a table, if it's in a table.
Yep.
The other thing I was going to say is, we were talking about this in the pre-calc videos, because they're doing calculus right now in pre-calc. The directions for A and the directions for B aren't any different. I don't know if like you guys realize that, but if the directions for A say find the slope of the line tangent to the graph of f at x equals pi, you're finding f prime of pi. And this one is saying find k prime of pi. I know they're on different functions, but they're saying the same thing, right? The slope of the tangent line at a certain point is the same thing as the slope of the curve at a certain point, which is the same thing as the derivative at a certain point. Like, they all mean the same thing. The instantaneous rate of change at x equals pi, that all means the same thing. So just reminding, like, all those directions really mean to do the same thing. Now you got a new rule, Mr. Honey.
Of course we do. C. Let m be the function defined by m of x equals g of -2x times h of x. Okay, so now we've got kind of chain rule and the product rule going on.
Woo!
Oh, so much fun. All right. Part C. We got m of x is going to equal g of -2x times h of x. Okay, so we have to find the derivative again. So m prime of x. Okay, so unless you're Connor, we all kind of do this the same way. You take the first times the derivative of the second, which is going to be h prime, plus the second times the derivative of the first. So the derivative of g of -2x is going to be g prime of -2x times the derivative of the inside, which is going to be a -2. Alright, so we really want to know m prime of 2 here. So let's plug that in. M prime of 2 is going to equal g of -2 times 2 is going to be -4. H prime, that's a weird prime, h prime of 2 plus h of 2 Actually, I'm going to bring this -2 out front just so I don't lose it. So it's really going to be -2 h of 2 g prime of -2 times 2 is going to be -4. Okay, so once again, we want to stop as soon as we can, but you're going to actually have to evaluate what each one of these things are. And they're going to be scattered throughout this problem somewhere. So let's begin with g of -4. So we got m prime of 2. So g of -4. We got a table here with g and g prime. So I want to know what g is when x is -4. So g is going to be 5 there. Then we want to find h prime of 2, which I think we already did. Remember h prime of 2 we did up here. H prime is the slope of h, so it's going to be our slope here again at 2. So it's going to be a -1/3 is our slope. Minus 2 times h of 2 now. So this one's a little bit trickier. So we want the point on our graph of h at x equals 2. Well, if we're going down 1/3, isn't this going to be a -2/3 that we're going down? This would be like -1/3, -2/3, -3/3. All right, so it's going to be -2/3. Okay, and then g prime now of -4. I'm going to go back to this table. G prime when x is -4, g prime is going to be -1. Yeah, so stop right there, guys. That's far enough. You don't need to keep going. All right.
Another way, if you don't reason your way through h of 2 as easily as Mr. Herney did, is if you thought about, okay, there's 1, 2, 3, 4, 5 different line segments, which they say in the stem of the problem. And this equation wouldn't be hard to write, right? We know the slope is down 1/3, so it'd be -1/3 for the slope. X, mx. The y-intercept is 0. So that would be the equation of just this line segment. And if I want to know what that value is at 2, when x equals 2, I don't really need +0. Oh, then y would equal -2/3. So like there's like an algebra way to do it if you like can't like reason your way through it.
Sweet. So before I talk about part D, we'll just talk about points. So save some space. All right. So we have part A here is going to be worth 2 points for finding f prime of pi. That's all it has in the instructions. I would assume you'd get 1 point for finding f prime and then 1 point for finding f prime of pi, even though it doesn't specifically say that. That would make sense to me. Part B, you're going to get 1 point for k prime. Okay, so you've got something like this written down for k prime, you get a point. And then you're going to get a point for evaluating it. Okay, you need to at least get to this part though. Okay, you don't need to figure out it's +1/3, -1/3 times -1 is good enough. Part C then is going to be worth 3 points. So this is a little bit trickier derivative. So you're going to get 2 points for having the correct m prime. Okay, now just one little part. It's going to be 1 point then. Okay, but if you mess up one little part here, you're definitely not going to get the answer right. And you get 1 point for having the correct answer. You don't need to keep evaluating all the way through. You can stop right there. You would end up with -3 if you kept going. All right. So let's talk about part D then. So part D here is asking, so many papers. Is there a number C in the closed interval -5 to -3 such that g prime of C equals -4? Okay, so here, I know I've talked a little bit about this before. It's asking you, does there have to exist a derivative that equals -4 on that? Okay, so let's start thinking MDT. Do it. know, this thing's being weird.
It's kind of glitchy.
Yeah, it is. All right. Before you get into it, you need to say and give our hypothesis statement, okay? So we know that G was differentiable. G is differentiable on -5 to -3. Okay? Typically, you just need parentheses on these, but it did say G is differentiable and didn't specify for where, so it's really anywhere. So G is differentiable on that interval, therefore it's continuous on that same interval. And MVT holds true. Okay, so now we really want to talk about the IROC equals AROC. So we're talking -5 to -3. Okay, so sometimes you're going to have to do like smaller intervals on it if our major interval doesn't end up equaling the value we need. So for when I do this, I'm going to start with G of -3 minus G of -5 divided by -3 minus a -5. And we'll just see what happens with this. So you know G of -3 is going to be 2. Minus G of -5 is going to be 10. All divided by 3 minus a -5. So it's really going to make a 2. So this is -8 over 2, which is -4, and that's exactly the value that we're trying to get to. Okay? So now we just need to come up with kind of our conclusion, kind of just restating what we were asked to find. I'll write that over here. So there must exist a C where C is going to be in between -5 and -3, such that G prime of C is going to equal -4. Okay, so all we're really saying here is, so there must exist a C on that interval where the derivative of G is going to give you that -4. All right.
Or the line will equal the slope of the tangent line. Right? Like
Yep.
visually it's where they're parallel, if you guys remember.
The IROC.
The IROC equals 0. So points
Cool.
on that.
Oh yeah, points on this. So guys, you're always going to get your 1 point for having this. IROC equals A